Hello, in this video we're going to be talking about trigonometric integrals. Specifically, we're going to be working through example 1 from section 6.2 on trigonometric integrals. And example 1 is illustrating the first strategy for evaluating trig integrals, which is to rewrite the integrand in terms of sines and cosines. Now, the first thing that I want to mention about the integral that we're evaluating here, the integral of tangent x dx, is normally this is something that we can just memorize. Okay, so in the future, you can simply memorize this integral. It is one of the integrals given in the lecture for this section, so you can simply memorize it and then apply it. But it is a good example of using the strategy of rewriting an integrand in terms of sines and cosines, so this is where we're going to start. So for the solution here, we are going to take the tangent of x and rewrite it in terms of sines and cosines. Specifically, tangent x is sine x over cosine x. So we have the integral of sine x over cosine x, and from here we're going to use a substitution, which is extremely common with trig integrals. Specifically, we're going to say let u be the cosine of x. Now, that means that the derivative is going to be negative sine x dx. So notice we have a sine x dx in our integrand, so I'm going to move the negative over, so I have a negative du is equal to sine x dx. Now you may have been tempted to let u be the sine of x and du would be cosine x, but the issue with that is that cosine x is in the denominator, so it doesn't really work out for a substitution. So notice that u equaling sine x doesn't work because du is equal to cosine of x dx, but cosine of x is in the denominator. Alright, so that doesn't work out there, but the u that we chose, u being cosine of x, does work out. So now, going back to our integral, we are going to have the integral of negative du over u, or we can pull the negative out, so we end up with negative integral of 1 over u du, and we know that is natural log. So we're going to have negative natural log absolute value of u. Of course, remember to add our plus c. Substituting back in for u, we are going to get negative natural log absolute value of cosine of x plus c. So this is one of the antiderivatives of the tangent of x. You will also sometimes see it written as natural log absolute value of secant x plus c. And this is true because of the fact that we can take the negative and write it as an exponent because of the natural log property. So this is equal to natural log absolute value of the cosine of x raised to the negative 1 plus c, and cosine of x to the negative 1 is just secant of x. So there are your two options for memorizing in the future. The integral of tangent of x is equal to negative natural log cosine absolute value of cosine x plus c, or natural log of secant x plus c. But as far as this example goes, it's a good illustration of rewriting a trig function in terms of sines and cosines so that we can then use a substitution to evaluate.